So, hydropower plant. Generally, the electricity by the hydropower is one of the cleanest methods of producing electrical power. Hydroelectricity is the most widely used form of renewable energy. In this power plant, the power plant, first of all, power plant definition is the plant where the electrical power is generated. If the electrical power is generated by means of hydel power, then you called it as a hydropower plant. So, in this power plant, hydel energy is required to run the hydro turbines. So, these hydro turbines are the mechanically coupled to the generator to develop the electrical energy. Suppose here in this animation picture, here the green color rotating one is the turbine. Outer periphery of the turbine is arranged with some buckets. Here water is passed through the forcefully on the buckets. When due to this water force, the buckets will move. Though the entire turbine will rotate like this. This turbine develops mechanical energy by means of the hydel energy. Now this mechanical energy is transferred to the generator by means of mechanically coupling to this generator. The generator will generate electrical energy by taking mechanical energy as the input from the turbine. So this is about the concept. Next, coming to this layout, this is a layout of the hydropower plant. So here the basic components we will discuss in the next slides. So the first one, a dam and reservoir. So in order to create electrical energy from the hydel energy, we need to store the water. So in order to store the water, we need to construct a dam. Here the water is stored behind this dam. The place where the water is stored, you called it as a reservoir. Okay, so the dam is generally constructed on a large river in hilly areas to ensure the sufficient water storage. Okay, and the dam forms a reservoir, large reservoir behind it. The height of the water level in the reservoir determines how much potential energy is stored in it. Okay, so this height of this reservoir, the height of the water level in the reservoir, that you called it as a head. As level as the head increases, more amount of potential energy is stored in the water. That's why. The next one, valve house. This is a valve house. In some literature, they called it as a control gate also. So here, water from the reservoir is allowed to flow through the penstock. The amount of water which is to be released in the penstock can be controlled by this can be controlled by a control gate or valve house. When the control gate is suppose fully opened, a maximum amount of water is released through the penstock. Clear? Suppose if it is opened partially, a limited amount of water is passed through the penstock. So next one, penstock. What do you mean a penstock? Penstock is a large steel pipe. It carries water from the reservoir to the turbine, and the here the potential energy of the water in the reservoir is converted into the kinetic energy as it flows through the penstock due to the gravity. Is it right or not? When maximum potential energy is there, a maximum kinetic energy is developed. Okay. Next, water turbine. Here, the water turbine, water from the penstock is taken into the water turbine. The turbine is mechanically coupled to the generator, mechanically coupled to the electrical generator. The kinetic energy of the water drives the generator, drives the turbine, and immediately the generator gets driven. Okay, so there are as the kinetic energy is more, then the turbine mechanical power developed by this turbine also more. The same mechanical energy is given as the input to the generator. Okay, when after this conversion of this kinetic energy of water into the mechanical energy of these turbines, the water will flow out and collected in the draft tube. After then, it will passes through the river. Generator. A generator is actually mounted in the powerhouse. It is mechanically coupled to the turbine shaft. When the turbine blades are rotated, here the turbine blades are rotated, it drives the generator. Electricity is generated, which is then stepped up with the help of the transformer for the further power transmission purpose. Okay, next, surge tank. Here these surge tank are usually provided in high or medium head power plants, which are considerably long penstock is required. A surge tank is a small tank which is open at the top. Here, then the top side it is open. It is fitted between the reservoir and the powerhouse. Here, this is a powerhouse. This is a powerhouse where the power is generated, and this is the reservoir. Here, the surge tank is located in between the reservoir and the powerhouse. The water level in the surge tank rises or falls to reduce the power swings in the penstock. Actually, when there is a sudden reduction in the load on the turbine, the governor will closes the gates of the turbine. Okay, governor is a one mechanism which will control all the operations. So it will close the gates of this turbine to reduce the water flow. This causes pressure to increase abnormally in the penstock. This is prevented by using the surge tank, in which the water level rises to reduces the pressure. On the other hand, the surge tank provide excess water needed when the gates are suddenly opened to meet the increased load demand. Okay, that is the purpose of the surge tank. And coming to the working of this hydropower plant, just now we discussed all the basic components in the hydropower plant. Here, this animation picture will clearly indicates what is the direction of the water inflow into the turbine, and how the turbine blades are rotated by the motion of this water, by the motion of the kinetic energy of this water, how the turbine blades are rotated. So here the turbine shaft is connected to the generator, so that's why you are giving mechanical energy as an input to the generator. The generator will generate the electricity. It is the generator principle is already discussed in the second chapter. Now the electricity generated by the generator is collected is transmitted through the transformer, and this is a transmission line indication. So this spark indicates how the power is transmitted through the transmission line.